So we have calorimetry, which is a lab procedure to measure the heat flow or heat transfer between substances. If it's a heat transfer or heat flow, we are going to use the formula Q equals mc delta T, but calorimetry itself is a lab procedure to measure heat flow. So in our lab, we're going to be burning different kinds of foods, and we're going to need to measure the heat given off. So the first thing we need to do is we need a volume of water. Now the water is a medium for measuring the heat flow. Heat is going to be given off when we burn our substance, and it would normally be given off to the air, but we have a hard time gathering that air because air is a gas and it's going to travel fast. But if we were able to capture the heat into water, which we could contain in a container, easily measure the volume, easily measure the temperature change, then it would be much easier. So that's what we'll do. We'll need an initial temperature of the water because we need to figure out how much it changes. We'll measure the mass of your substance. This is the food. We're going to need that for later calculations. We're going to burn the substance, and you're going to measure the final temperature of your water. So we'll have where we started and where we ended. So Q for the water. So this is how much heat was gained. So if we know how much heat was gained, we should, by inference, opposite, know what was given off. The substance would have a positive Q because it absorbs heat from the substance. The substance, whatever food we burn, should have a negative Q because it released energy. And we assume no heat is lost, which of course probably we would lose some, but the assumption is we would not. So I am a terrible artist, but go with me here. You are going to have a little piece of metal, and the metal is bent, and tape it to either the lab bench or a ceramic tile, and that metal conducts heat and electricity. So on the metal you put a piece of food. So here's my piece of popcorn. Okay, so then we're going to burn it, light it on fire. So now this is going to be like a cut through. Over the top you're going to put your big calorimeter over the top, which has holes on the bottom, and this calorimeter is a metal can, and hanging over the top we have a cardboard can, and in the cardboard can we have water. Okay, so all the heat given off by this burning popcorn is going to go into the cardboard can, into the water. The metal here is going to conduct the heat away. The cardboard is going to absorb it. And so then we'd stick a thermometer in here and we'd measure the temperature change. That is a terrible drawing, and I apologize, but hopefully you'll get to see it in the lab. So there's that. If you are in the honors section, please continue watching. If you are in the regular college prep, you're all set and you can end. There's no more notes for you. So this is for honors. So the kinetic theory of heat and temperature says that matter consists of small particles that are constantly in motion, and that temperature is a measure of the average kinetic energy of these random particles. This is not anything new. It's just giving us a new theory. If you are heating something, you're gaining kinetic energy. You're increasing the temperature. If you're cooling something, you are losing kinetic energy. You're lowering the temperature. I don't think that's very new, but just the idea of this kinetic theory of heat and temperature is something you should know. Interactions between electric charges. Two types of charges exist in nature, positive and negative. Opposite charges attract due to electrostatic forces. The closer the charges, the greater the force. Farther apart, force is lessened. Yep, hopefully you know that. Conservation, we talked about the law of conservation of mass, the law of conservation of energy. There's also conservation of charge. When opposite charges of the same amount are brought together, their charges cancel out. However, and here's where it looks like the other ones, charge is neither created nor destroyed. An electric current is the flow of electricity connected by a wire. Okay, so this is honors only material, and thanks for watching.